Hello and welcome. This is 04 nth roots again with real exponents part B. We're going to be talking about simplifying expressions in rational form today. So rational exponent form. So the rational exponent form of roots expresses a root as exponents. So specifically the nth root of a number a can be written as a raised to the 1 over nth power, which we kind of talked about this at the end of the last lesson. So if we have the nth root of a, that's actually a to the 1 over nth power. So, and just a reminder, if we have a square root of, let's say, 7, this is actually equal to 7 to the 1 over 2 power, because we have a 1 up here and a 2 here. Those are invisible numbers, but we can write it that way. So this applies for everything, and this is kind of what we ended with on the end of part A. So let's take a step backwards again to Algebra 1, Algebra 2 rules of exponents. The product of powers rule basically says if we have the same base and we have an exponent of those bases, and we can add those exponents. So a quick example would be like 2 to the 7th power times 2 to the 2nd power, which they both have a 2 as the base. Those have to be the same, so a is the same, and then we can add the 7 plus 2, so this will be 2 to the 9th. Now we can physically do this very easily, so like if we think about 2 to the 7th power, this is 2 times 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7 of them, and 2 to the 2nd is equal to 2 times 2. Well, if we count up 7 and 2, that's 9 of them, hence where it's exponent of 9. Now the quotient of the power rules is if we have the same base again, and m divided by n here, we're going to actually subtract the exponents. So a quick example again, let's just do 2 to the 5th over 2 to the 2nd here, and this is equal to the 2 to the 5 minus 2. We're going to subtract those because the base is the same, which is 2 to the 3rd. Which again, if we have 5 2's on top, 1, 2, 3, 4, 5, those are all multiplied, put 2 2's on the bottom. Remember, those will reduce, and we're just left with those 3 2's, which is where that comes from. So a couple more rules of exponents. We'll talk about some negative ones in a little bit, but we're going to talk about power of a power rule, which if I have a to the m to the nth power, we're going to actually multiply. So if I have 3 squared all the way to the 4th power, what that means is we're actually doing 3 squared times 3 squared times 3 squared times 3 squared, which now I have 2 3's, 2 3's, 2 3's, 2 3's, which is 8 3's, which is 3 to the 8th. Which if we just multiplied these two together, 2 times 4 is 8. So 3 to the 2 times 4 is actually equal to 3 to the 8th. So it's a simpler way of getting the same number instead of writing out all of that work. Now if I have something like a times b inside of parentheses with the n, it kind of distributes to both here. So for instance, an example, if I have 2, let's say n to the 3rd, and I put it to the 4th power, this actually goes to the 2, so it's 2 to the 4th, as well as it goes here. So this would be n to the 3 times 4, which is n to the 12th. So that would be my answer here. And you can indeed simplify 2 to the 4th as 2 times 2 times 2 times 2, whatever that is, which is 16. So let's go ahead and just simplify some exponents and things. And we're just going to start by a simple thing of multiplying. So we have 3v squared, and we're multiplying it by negative 7v to the 6. We're going to kind of combine like terms. We have to multiply like things. So what we're going to do is we're going to do 7 times, or that 3 times that negative 7, and then we're going to, I'm just going to rearrange this as v squared and then v to the 6. So I'm going to multiply the numbers, 3 and negative 7, the coefficients of this, and then I'm going to multiply the variables together that are the same. So I look at this, I can multiply 7 times 3 in my head, and then take along the negative, which gives me a negative 21. And then there are 8 v's here because we add the exponents, so this is v to the 8th. So this would be my final answer here. Now using some more properties, we have all of this to the 5th power, which remember this 5 will go to everything here, And just be careful because that -2 will be in parentheses. Whenever you're dealing with negatives, you should keep parentheses around it. So in this case, we have this -2, but it's all in parentheses because we want all of the -2, not just +2, we want -2. We put that to the 5th power, and we have b squared all to the 5th power, and then we have a all to the 5th power. So basically I take each part of this and put it all to the 5th power and put those all in parentheses. You can do this step in your head, but I like writing it down just for reference, and then I just simplify each part and then it's good. And I like to put things alphabetically, so I'm going to switch A and B around eventually in my final answer. So if I think about this right here, -2 times -2 times -2, so 2 times 2 is 4, then times 2 again is 8, then 1632. This ends up being equal to -32. We like the number first, the coefficient. We have a to the 5th. I'm going to start with a's. And then remember those would multiply 2 times 5, which is to the 10th power, so b to the 10th. So this would be my final answer here. So let's do another one of those. Again, we will say like -6. We put it to the 2nd. We're going to put that in. Again, put it in parentheses. I can do y to the 4th to the 2nd. We can do z to the 3rd to the 2nd. And then we can simplify there. So -6 squared, which is -6 times -6, turns into positive 36. Remember, multiply those. So that's y to the 8th. Again, z to the 3rd times z to the... So 3 times 2 is 6, so remember we're multiplying when it's a power rule, we multiply, and that would be my final answer. Again, alphabetical, X, Y, Z. I would take points off on a test or a quiz if you are not putting this alphabetically, and especially if you don't have the coefficient in front here. So go right ahead here and check if you can find this answer here. Pause it, and I'll have an answer shortly. So you should get 64, 4 times 4 times 4, a to the 9th, again put alphabetical, and then b to the 3rd. So our last rule today is rules of exponents, the negative exponent rule. So a to the -n is actually the reciprocal, so it flips it upside down. So for example, if I have 7 to the -2 power, this changes into 1 over 7 to the 2 power. So the negative just says we're taking 7 squared but putting it on the bottom, which we could simplify to 1 over 49 if you like. Now the other way around, so if I said something like this, if I had 2 over 3 all to the -3 power, what this says is we're taking this -3, putting it to the 2, and we're taking it, putting it to the 3. So I can rewrite this like this. So this is 2 to the -3 and 3 to the -3. Now, because there's a negative on the numerator, this actually moves all of this to the bottom. And since there's a negative on this one, this moves it all to the top. So it kind of flip-flops. So we're going to rewrite this as 3 to the 3rd on the numerator, and now 2 to the 3rd on the denominator. Now it's just simplify both. 3 to the 3rd is 3 times 3 times 3, or 27. And 2 to the 3rd is 2 times 2 times 2, which is 8. So that would be that. So that's another example. So something else to consider is like if I just had 1 over 2 to the -3, there's this -3 is just attached to this. This will actually move up, the 1 stays there. And we can actually let's put a 7 here, just for fun. So this is actually equal to 7 times 2 to the 3rd, which you can multiply that out, which ends up being 56. So 7 times 8. So let's do an example. So again, we're going to take this, and this distributes to all of them. So let's write it that way. So it's 4 to the -3rd. Remember, I like putting everything in parentheses because we're taking a power to a power here. So it is important to have that. Now, because of that, we can simplify this next thing. So this actually will move underneath in just a second. So let's just think about what will stay on top. So this is 4 to the -3rd, which, well, let's put it down below. So it would be 4 to the 3rd goes on the bottom. So this is y to the -12th. So let's just keep that up there as y to the -12 for now. And then this is times z to the 6. So that actually changes to positive when you multiply those two. Now, because there's a negative here, this one actually will move to the bottom. So let's move in some room here. So on the top, we still have z to the 6, and the y to the 12th goes to the bottom. So we have that y to the 12th, and we still have 4 to the 3rd, which is 4 times 4 times 4, which is 64. So now there are no negative exponents, so that's good, and we have the number in front, and it's alphabetical as far as I know, so this should be good. And it looks like I accidentally erased that right there, so 64. Let's do one last example together. Again, we're going to take this and move it here, and we kind of distribute it out. And don't forget to bring it to this 3 as well. A lot of people forget that. So in this case, it's b to the negative 4th, all to the negative 3rd, and then 3 to the negative 3rd, and then we have that a squared to the negative 3rd. Again, I just use parentheses everywhere when you're kind of distributing things. This is a type of kind of distribution. It's a power property, power of a power, but it kind of has that same flow. So in this case, when we simplify that, it ends up being b to the 12th on the top because it turns positive. 3 to the negative 3rd, we can move that up as 3 to the 3rd on top. And then a to the negative 6, which we can move that up as just a to the 6, which then there's only 1 left on the bottom, which we can resimplify this as 27, a to the 6th, alphabetical, and then b to the 12th. And that would be my final answer here. So please try this on your own. I will have an answer shortly, so pause it. So you should get w to the 8th on the top and 81x to the 24th on the denominator.